24 moving around. I probably should have used it first, didn't I, before I rummage around. Yeah. This is one. I suppose normally I walk around like anything I do, but if I walk around with this stand, the very board you're looking at, so I'll have to see how it goes. I think we all, if you don't need performance, then sometimes there are better choices than libraries in C++. There are some sharp edges that we cut the fingers on quite often. And so, maybe performance is a reason to pick C++. I've done a presentation about the multi-paradigm nature of C++ before as well. One thing you get with other languages is that sometimes they force you down a particular hole. Either you have to do things object-oriented, or it's purely functional, or it's somewhere in a data-oriented design way, whatever. But with C++, we can mix and match those ways as we see fit, and in fact, different parts of the same program can use the different approaches, and that's all fine. So maybe that's a superpower. And if you had asked me prior to this talk what I thought the superpower was, it's the clear object lifetime, or RAII, or whatever the other acronym is that people use these days. I didn't remember there's some other cute acronyms for it, but anyway, you know, destructors is what I'm saying here, right? So obviously, if you post anything on the internet, you get responses that you weren't really planning to hear. So when I said, what's the best thing about C++, inevitably, I got a big list of things that people hate about C++, and I'm sure your favorite thing to hate about C++ is on this list, right? You know, UV, right? There are some terrible defaults, you know that. You know, we have to drag around the millstone of the previous, like 100 years, it feels sometimes, of the language with us. And the syntax can be somewhat confusing because we are, except for the one time when we sort of added a couple of new keywords, most of the time we kind of get away with using different types of brackets and chevrons and things to try and get away with actually not committing to a new keyword. But today, I'm going to attempt to convince you that these middle two are actually the superpower of C++. Because what these two give us, horrible as they are, is backwards compatibility. Now, you may think to yourself, I don't care about backwards compatibility, and maybe you don't, but I'm going to try and make a play for it, and hopefully by the end of this you'll see what I mean at least, even if you don't exactly agree with me, and hopefully it'll be a fun journey. I'll let you be the judge. So, the way that I'm going to prove to you that backwards compatibility is awesome in C++ is I'm going to take some ancient code, older than some of the people in this room, and I'm going to port it to modern, and I had to put these quotes in actually when I read the slides, C++ 17, because no longer is C++ 17 all that modern, I realise, but we're starting with C++ 17 in this particular project, and I'll talk about some of the C++ 20 and even 23 things with some vague hand-wavering. Was that Michelle, you got a question? Yes. Maybe we could actually say, Michelle made the point that C++ 11 is modern to some people, and I think that's a very valid point right here, right? And compared to code that is old enough to drive and drink in this country, you know, anything's modern. So, and the real key to the backwards compatibility story here is I'm going to do this port incrementally. This is not me taking a giant code base from before and then rewriting it, and then at the end kind of crossing my fingers and hoping that it is the same as it was before. This is me almost line by line changing it from an ancient, frankly, bit of K&R sort of era C into somewhat modern C++. So the question I'm sure you're all thinking is, where on earth am I going to find such ancient code? Especially if the code needs to be something that I understand well enough to be able to report and talk about in a meeting like this, right? So what was happening 26 years ago? Oh gosh, the time ticks on by slides, the year passes. 1996. So for those who were alive in 1996, Wannabe was in the charts, which is still an excellent song. I don't fight anyone who says otherwise. We were struggling with USB for the first time, the 3 incorrect ways that you have to rotate USB before it actually goes in. We all know about that. And I was doing a physics degree, or I was supposed to be doing a physics degree in the UK. That is indeed me, yeah, I know. It's very much Harry Potter now I look at it, right? I just need a scar. Yeah. And what I was doing instead of a physics degree was spending an awful lot of time in the computer lab playing MUD. Now, by a show of hand, if I said what a MUD is, I can see one nod at the front here, there's one at the back. There's a few very confident hands, and there's a few sheepishly like, yeah, me too. So what a MUD is a text mode adventure game, but it's a multiplayer one. So if you remember those games that you might have read out, retro games, where the computer describes to you with text, you're in a room filled with treasure, there is a dragon on the pile of treasure, that kind of thing, and you do like go north, kill dragon, and that's your sort of interaction with it. That is a MUD, except that the MUD is online, by some definition of online, and it is multiplayer, so you might see some of the other characters would be other people that are playing. So you can chat to them, you can team up, you can fight dragons together, all that kind of good stuff. So it's kind of Dungeons and Dragons online. Think budget EverQuest or World of Warcraft. And I mean really budget, because it looks like this. So I actually, after playing MUDs for 2 years, I decided I'd write my own one with some friends, essay write, heavily adapt some source code that we found around, knocking around on the internet. This is all very much before GitHub and all the good things that allow us to share it, and it was open to the public. It was public domain source code. I haven't like stolen and done some licensing trouble. I haven't got into trouble there. But it was harder to find this stuff. You had to use find the right FTP site or know the person who had the code, and then you get hold of it. But anyway, so this is what our mod looked like. So this is me and my university housemates. We ran this multi-user dungeon together. The Wayback Engine still has a picture of what it looked like. At least some of the images are there, not all of them. And this is, your user interface. It is, a wall of text. The color, incidentally, was one of the bigger features that I added to the base source code. And this is one of those what goes around comes around kind of things, because the MUD that I used to play asked us where we'd gotten the code from, because they got back into our MUD, and they go, oh, where did you get the color from? And I said, oh, we did that ourselves. And so we sent them the patch file, and so, I still have a credit on it. That one's still running, that MUD is still running amazingly. As is this, but we'll come back to that. So yeah, this is what a MUD looks like, and it's, maybe some of you will go like, yeah, I can see how you could get lost in that for hours and hours and hours. And maybe other people are like, what on earth are you doing? But whatever. So what is a MUD? What is the program itself? What is the server at the other end of this connection doing? It is essentially a massive text processor. All it's doing is ingesting text from files that describe the layout of the rooms, and which rooms connect to what other room, what objects are in those rooms, what monsters there are, how many hit points they have, all that kind of nonsense. And then it's accepting commands over telnet that say go north, so it has to separate the text into words and then work out what to do with them. So it's just text processing, which of course is not really C. This was C, this program. It's not really C's sweet spot, right? If you think about internet-connected programs that are open to the world, that are written in C and primarily take user input, that's not a good mix. It's a miracle we didn't have more security issues than we did. And you'll see some of the horrible bits of code in a minute, and you'll be even more surprised. So how did I take this 25-year-old code and bring it kicking and screaming into the modern era? Well, the first thing is I had to find the source. It was on one of these disk drives in my basement. I hope nobody throws away old disk drives, right? You just put them in a box, because they're wonderful keepsakes, right? You can go spelunking in there and find all sorts of wonderful things. The problem is half of these were like RAID disks, And then it was playing the funny game of like which disk went with other disk, which one was the primary and the secondary, and all that kind of stuff. But I'll let you into a secret. This is my box of hard drives, and I do occasionally go looking at them. My microcode was actually in like a subdirectory of backups from previous computer, which was this like a subdirectory of backups from the previous computer before that, and it was in one of those directories somewhere deep on my own machine. So what are we starting with? Well, I know I've been saying it's written in C. There's a decent amount, 700 lines, of C++ as well. This is my very first C++ that I wrote. And it's terrible, and for the purposes of this talk, we're going to ignore it, because it's so bad. But we have 50,000 lines of C, and nearly, we've got actually more Perl and make than we have C++. So, you know, make files being what they were back in the days of Unix, you know, it's a lot of complicated things going on in there. And 50,000 lines of code is not a huge amount, but it's not trivial either. It's just 50,000 lines of non-comment code, non-actual lines of proper code. Gosh, the weather out there is absolutely awful. So those who are watching on Zoom may also be seeing the tornado warning, but we keep getting these tornado warnings here. So if we suddenly all run out of the building, you'll know what happened. All right, so even before I start this sort of porting C to C++, I'm going to do some amount of sort of just general cleaning, cleansing, data cleansing. Right? I'm going to put it in Git for a start. I'm going to get rid of all the janky make and make use CMake, which is not my favorite thing, but it serves a need. I'm going to clang format the whole code because there's a mixture of spaces and tabs, and you know, we can have a fight about which one's the correct one afterwards. I don't care actually, as long as it's consistent, that's the only thing, right? I am going to compile with all extra, and I'm going to turn on all the sanitizers I possibly can, and I did actually pick up a whole bunch of things in the original C code. And my intention was not to fix as I ported it, was like, no, let's just get our house clean first in the original code. So there were a number of things that were undefined behavior that was relying on before. They were mostly benign things like using signed numbers in bit masks and shifting them up, which would have been fine. I could see that they were always like unsigned values, but the compiler was like, but it might not be. So I fixed those. I introduced Conan, which is, you know, take your pick of like library dependency management systems. And of course, we didn't have any dependencies, but I was going to introduce some because I'm going to do some testing in this horrible jank bit of code, and I'm going to do some things with some of the more sophisticated libraries around. So it's nice to have that around. And then, of course, having done all that stuff, I ran and I tested it, right? And it was kind of like, this seems to work, right? The sanitizer isn't complaining, everything's compiled, it's all good. Oh, damn, oh gosh, I forgot about this slide. All right, so you obviously want to see what a mud looks like. And of course, I just rebooted my computer to get it to work with the video, so you now actually have to, all my careful preparation. So there it is. This is the beautiful loading screen. And I have to, multi-character. Here we are. My password under pressure. Okay, some gameplay updates. Now, we are still developing this. One of my college roommates is still working on this with me. I haven't touched it for months, actually. He's the person doing all the hard work, So, you know, here we are, we're in the common square, you know, people passing, talking to each other, ha ha ha, all these things. To the north, there's some things, there's a variety of exits. I could go north, I could type in end return, and now we're in a new room, and there's a city guard here, and there's an eagle apparently in this room. And if I leave it like here long enough, actually, Concordius is not gregarious, he's just left, right. He wanders around, he's like the town law keeper, so he wanders around, and if you're fighting, he'll come in and join on your side if you are aligned good, and they'll start fighting you if you're aligned bad, all those kinds of things. Right. You get the idea. If I go south, there's a rat, I can kill the rat, so kill rat, and because I'm at level 12, I am the one person locked into this blood at the moment, unsurprisingly. I'm a level 12 orc mage, apparently, and I can kill a rat really easily, so that wasn't really much of a fight. But otherwise, it'd be like a turn-based D&D style. You hit them for 10, they hit you for 3, you know, then you can cast a spell, all that kind of stuff. So you get the idea, and it's not all that scintillating, so I'm going to log out. And if I click on stop logging, it isn't. Okay. So I've laid the groundwork, we have a whole bunch of C, ignoring my horrible C++. And now we're going to turn it into C++. And the way we're going to do that is we're going to rename all the C files to CPP and all the H files to HPP. And we're done! We're on Ninja, everything is great, right? Or is it? Pop quiz. I know this is all about backwards compatibility, right? But you have to suspend that for a moment while I say that What small C program is not a valid C++ program? Can you just think of anything off the top of your head? There's a, go on, Lou. Do you want to share out your answer?
If it uses the new keyword.
If it uses the new keyword, and literally a new keyword, like the new keyword is what you're saying, yeah, the new keyword, yes. So let's have a think about what things might be a problem in the context of a MUD. So here's a little Venn diagram. On the one side we have C++, and on the other side we have Dungeons and Dragons. Someone shout out what goes in the middle here. Class, correct, yes. So yes, the code has, this is, I mean, even my syntax highlighter here has gone, no, this is a keyword. It's like, no, it isn't, this is C. So yeah, you know, there's a ton of stuff that said class. And I say a ton, there's actually not as many things as I thought. Most things had enough other underscore bits whacked on the end of them. It was like cast or character or something that it was fine. Also template here, you know, we've got strings that are templatized in some way. It's like, oh, I'm going to replace the %s with the name of the character that's casting the spell. So it was a template string. So that was a pretty trivial rename, and we're done. But it was quite funny to kind of be knocked over by that, and very particularly because it's a MUD. So my general process is going to be, I'm going to make a tiny change, as small as I can reasonably make, and then I'm going to test it. To start with, that's just going to be literally manually, and then we're going to get to some TDD kind of cool stuff. And then this is a key that I just want to leave you with. This has got nothing to do with this presentation at all. It's all about giving yourself the permission to make small changes, because small changes are better on you and the person who is maybe going to review your code in a professional environment or even in a toy project like this. To the extent that it's okay and safe to do so, leave it to do if you see something which can be improved, so that A, you won't forget it, and B, you're not tempted to pull on that string as well, and before you know it, you've checked out the entire code base and everything's changed, and you're like, hey, can someone review my change? And everyone starts edging away from you, like, no, not today. So give yourself permission to leave some to-dos. My trick with to-dos is to always link the to-do to either a Jira ticket or a GitHub issue or insert your poison, like just the number or something, just so that you can track it and you can say, oh, this goes to with this sort of thing. You can point to the management and say, hey, I've got a whole bunch of tickets that are just like, you know, clean up code, clean up changes, or put your initials in there or whatever. Anyway, we're going to use 3 techniques, one of which you'll recognize, which is TDD, I hope, test-driven development. The other 2 we'll come to. Okay, we're going to see some code here. There's going to be quite a lot of code, I'm afraid, and I hope that's big enough for you to see. I know at the back that might be a bit directed or I obviously, originally this was for an online presentation. I don't know if I can zoom this anymore. I'm not sure I can zoom it because my slides scale to fit what they think they've got available to them. So I'm apologizing ahead. I'll try and shout out what I can from here. So this is the bit of code we're going to be looking at. It is a structure. It's just struct area data, and it has a next pointer, it has a char star name, it has 2 ints, 2 underscore ints, which is obviously just shorts, a bool, and another couple of char stars, and then an integer. And at the very bottom it says type def struct area data, right? Because that's what you had to do in C. You didn't, the names of classes weren't themselves names. They were always had to be referred to as struct blah, if you wanted blah. And then if you wanted to make it short for yourself, you had to type def some other name to be that, or sometimes you could use the same name. So what things can we change here? Well, things we definitely want to get rid of. There's a hand, you know, the next pointer implies there's going to be a hand-rolled linked list here. Nobody should be writing linked list code in 2022, right? No, we've all done it. We've all proven that it's okay, and then we're like, I'm very happy that somebody has done this for me and I never have to do this again. So we're going to get rid of that. We have some char star names, which are mutable C-style strings. Now, of course, back in the 90s, you know, we were a bit more lackadaisical with our constancy, let's say. And so everything that would have been, you know, we just use char star everywhere instead of const char star. But we don't even want to use const char star. We want to use like some std string or something that's going to manage it for us, right? So that can be changed. We know that this type def struct thing is unnecessary. We don't have to do that anymore. And I think it's not working. There's a global down here. This external area data star area is horrible. We want to get as global as we can. And then the whole thing, obviously, is just a structure. Every single member of this is public to everyone, and so the dirty washing of this class is exposed to anybody who wants to come and look at it. I suppose I should say what this class is actually, what an area data is. I forgot to do that. So area data in this context is like a group of rooms that logically go together. It's effectively one level of the MUD. It will be one text file. It will be like, this is Midgard, and there are 100 rooms, and there's 200 mobs, and the mobs go in these rooms, and the objects look like this, and that's what they go. So that logically is an area file. And this is just the metadata about that block of rooms and mobs and things. It's not very exciting in terms of what it actually does. So there's a question from JS. There's an excellent point. There was no bool keyword in C. It must have been hash defined in some horrible header file that we were picking up then. There was like the one merc.h which we inherited from the previous thing. But yeah, it's a very good point. So yeah, bool was obviously already something that had been taken away from the original language, not taken away by using. Good point. Thanks, Jay. Else? Right. So we're going to do the simplest possible fix we can do to start with, and that is we're going to get rid of that using type def. You see, I've already swapped type def for using in my head, but no, we're going to use using here. No, we're not going to use using. We're just going to get rid of it. We don't need it. We're just going to call this area data in shout caps because that's going to be the most commonly used name for the rest of the code base. This is the smallest change we can make. We compile it, we run it, everything's fine. Hooray! You can even check that in. Brilliant. I mean, there's nothing earth-shattering about it, but it's slightly better than it was before. I particularly like the fact that I get like a green bill from the CI, and then I feel like I've done something productive, even if it's not really that important, right? We choose your poison. So the next thing I'm going to do is I'm going to pick an element and change it. So this is just a subsection, for those who are on the back, subsection of that structure, and we can just see the char star elements. And the first thing I'm going to do is I'm going to change the char star name into string name. Literally one line change. And we've gone from a completely C program to the first, apart from my C program, to the first vestiges of something that looks like modern code. Like we don't have to worry about the lifetime of this anymore. Hooray. So we change to string name, and of course, we move on to the first of my techniques, which is not really my technique. Everyone in this room has done this. CEDD, or compiler error driven development. You know, this is how we actually do our work, right? You kind of like, the IDEs are getting better, right? I mean, there's very often, probably 7 out of 10 times, I can rename something my IDE and it works. 2 times and it just doesn't work at all. 1 time it renames the wrong thing, right? But then the rest of the time is you change it, you build it, and you see what happens. So that's exactly what we're going to do. The problem is, if I change my name from a char star to a standard string, what do you do with something that's got a name in it? You're probably going to print it out to somewhere, right? So here we have a bit of code, again for those at the back. It says void report area. It has char buff max string length, which we'll get back to in a minute. And it sprintfs without even checking that that's going to fit into that buffer, area code %s, p area name. Now, if you have ever looked at how printf works under the hood, you know that printf, or sprintf takes 2 parameters, which is where it's going to print it to, the format string, and then a ... which just says, hey, anything's fine. And so it doesn't know that this name, which used to be a char star, is now actually a standard string, and so it's almost certainly going to crash if it tries to do this. And so I'm not even going to get the help of my compiler at this point. Oh, highlights, and I forget about them. Except the wonderful compiler vendors have saved us. They actually know that printf is magic and special, and they know how to parse that format string in the compiler. And so what we can see down here is that the compiler has in fact complained that I'm passing a standard string, whereas expecting a char star because of the %s, which is marvelous. Question, Michelle? Right. I don't know anything about Visual Studio. You're probably right, though. There's a lot of tooling. So Michelle's saying that there's a lot of tooling support, and particularly in Visual Studio, which might do some things that might just be a hard error. In this instance, it is a hard error. I know it says warning. I've obviously done warn where ominous thunder there. That's what happens when you invoke the power of warn. So anyway, luckily the compiler has our back here, which is great. Except that in other cases, it's a simple fix, right? It's just put .c underscore stir again, which is great. Except that later on we're going to get rid of that again. But you know, it's one small step at a time. The other problem is that I have written some code in the mud where there was like, before stream exists, we sometimes want to have a buffer object that we're going to accumulate more and more messages into. And because I was feeling pretty cute at the time, I use a sort of printf style string myself here. I take a buffer star, which is an expanding buffer. I take the text, which is actually really a format string, and then I have a dot dot dot, and then there's the hideous macro VSR nonsense that's hidden away in the buffer here. But of course, now the compiler can't tell that what I mean when I say dot 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 here is it's like printf, right? So I don't get any help from this. But I can tell the compiler, hey, my function looks like printf. So what I've got here is a C++ style attribute, thank you, in front there. I'm brains falling out of my head. Yeah, an attribute that says, and this is a GNU extension, but it's supported by both Clang and GCC, and it says, hey, my function tastes like printf. And the 2 and the 3 here represent which one has the format argument in it, and which one is the dot 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 and beyond. So sometimes, you might want to, this might be later on, it might be that you take 2 R's yourself, for whatever reason, and then the 5th and onwards are. But you shouldn't need to do this anymore because we shouldn't be writing this kind of interface, but it exists and it's helpful to leg ourselves slowly into modern code. So now we're into the second DD, and this is the just run it and see what happens driven development, which is, again, something we all do, I think. And in this instance, the leak sanitizer comes out and saves us from ourselves. So far the compiler has saved us from the trivial silly error in the name, and now the leak detector has said, wait a second, we're leaking memory here. I'm like, how can I be leaking memory? I just took a char star, which clearly is like the most likely thing to leak memory, and replaced it with a beautiful standard string, which is going to clean up for me. Well, the code looks something like this, and again at the back it's a bit small, I appreciate, but essentially, to cut to the chase, the old code used to duplicate the pointer that it wrote into that name. It kind of like read it from a file into a temporary array, and it's like, well, this needs to fit longer than me, so I'm just going to strudup it. If you remember, strudup is the, like malloc the same amount of memory as it needs, and then copy it into the malloc and return it. So it's doing the duplication of the string, and then of course we're now assigning it to our standard string, which means we take another copy of it, thank you very much, and we'll say, well, we manage our copy, good luck with yours, and it leaks. So obviously the fix there is to not do that, it's just to read it into that. But this is the one I couldn't get easily auto-detecting. So it's just like, I remember now that every time this happens, anyone is assigning to one of these things, I'm going to have to check all the assignments. And with that, it started working. And I now have changed exactly one field with about 7 or 8 other changes in the code base. Try doing that in some of the other languages that have had major overhauls, right? You can't make a line-by-line change. Maybe you can in TypeScript. I don't know, there are some folks in here who maybe know better than me, but like a lot of other languages, you might have to make a whole new module and then kind of link your old code with your new code. But here we've just taken one bit in the middle of a structure. So that's pretty awesome. So obviously we can do the same with the area name and the file name. And those are terrible names incidentally. I don't know what the difference between name and area name is. We'll fix that in a minute, but we're not fixing too many things now. I'm not trying to change too much while I'm also fixing it. At least not while I don't have tests. So what's next? I'm going to get rid of this horrible pointer, the next pointer, and instead of having a global that says areas, I'm going to have a vector, a global vector. For those on the Zoom, we just had a massive crack of thunder. We all know that vector is the right container for everything, right? And indeed it is here. So here I'm now just storing a global. It's still a global, and you'll notice that I've given myself a permission to leave it as a damn global because I've only got one thing at a time here to do. So I'll put to do number 47, it's made up, but could correspond to a GitHub thing somewhere. Find a way to be global. So now I've got an array of all the areas, and we're done. No more linked lists, hooray. And this is what the code looks like. There's some bit of code that says load this area, give it this file pointer, it's going to do some parsing, it's going to in place the area just parsed onto the back of the list. And then later on, there's a bit over here that loads the rooms in that are associated with an area and says, hey, this room it has a pointer to the current area, and I'm just going to write in the current area here. And hopefully some of you are starting to smell the problem already. Yeah, good. You've all got good instincts. That's great. Because, again, the sanitizers come along and say, don't be so stupid. Keep use after free, which is not the most helpful error message, but what it's telling us is that there is a bit of code that's reaching into an error in memory that has been free. And as we've only made this one tiny chain, it's pretty clear where that memory must be. So it must be somewhere inside that vector. Because what happens when you expand a vector, it has to reallocate and potentially move things from one area to the other. And yes, that's what's happening here. So rather standing, the bit of code is somewhere inside the mud, it's trying to reach into a particular room's area, and that's the pointer that was stashed when the room was loaded is removed because other areas have been loaded afterwards. So, I can take all of these. So we need pointer stability, which is a shame. I don't really want to have to rely on pointer stability. So for now, I'm going to make it a vector of unique pointers to areas, which is, again, not brilliant. I put it to do to come back and look at it a bit later on. But another alternative would be to use a still list, which kind of gives us back the same properties that we would expect from the singly linked list that we had before. We can always use a still forward list, I think, is the actual exact equivalent of a singly linked list, which it was before. But I don't really like that. I think there's a way, and full disclosure, I haven't actually returned to this, at least to this is ever a growing bunch of things. But we'll solve one problem at a time. At the moment, we just got rid of the fact that there's a whole bunch of complicated code. You can imagine every time someone was iterating over a list of any things, they had to write their own bespoke code because there's no templates in C to walk through all of those texts. So anytime we can replace any of these bespoke containers with an STL type thing, we can start using all of the cool other C++ features. So now we get to the cool stuff. That was just like boring. I've got wrong beats everywhere. So now I want to classify or classify. I don't know how you do it. How do you make something into a class, right? Classify seems right, but it kind of feels like you're choosing which class is it rather than making it. Anyway. So the way we're going to do this is we're going to replace the word struct with class, which I think you know is exactly the same as a struct, except that everything's private by default. And then we're going to immediately make everything public again. And now we're in a situation where it should just compile. So there's our area data, and now it's class area data, public. And we can compile the code, and again, it's a bit of a hollow victory, but it's a victory nonetheless. I've compiled my code, it works, and everything. And now I can pick each one at a time and move it from the private to the public, sorry, from the public to the private, and make a decision about what I want to do with it. Now, we're going to start making some actual changes in the way the code works now. We're getting close to being able to test it. So I'm going to move the name up first of all, and then I'm going to write my accessor down here. And this is a read-only accessor where I'm just returning a constant string reference to the thing I made private. So there's a standard string now that's private, it's with name with a trailing underscore, which is my flavor of saying it's a name variable. And then I've added an accessor. But I haven't added a mutator. This is the first time I made a difference in the way that the code works. The obvious thing would be to add a mutator, which is like set name as well, and then rephrase everything in terms of set name. But the only place that ever wants to set the name is when we're loading it in the first place. And so why don't I choose to bring the loading code into the class and say, okay, you're intimately involved with this class. I might as well move the code in, and now you can write to your heart's content all of the private variables because you're logically part of this class. So that was the first step in making it actually an object instead of being just a bag of bits. And obviously you can do the same with the file name and the area name, and now we're in a good world. Because all of these things, again, will write sort of essentially write once. Michelle? Absolutely. So Michelle's suggesting making a constructor, and my thought there would be that yes, that's where we're going to go with this. I actually made a determination not to use a constructor, and I'll talk a little bit about why, but it is obviously what you could do here is make a constructor. Of course, there's a ton of other fields in here that I'm not deliberately not initializing at all yet because they've still got like default C behavior. But as it turns out, they're all going to get initialized in parts, so it's kind of a one-shot initialization. And parts could be just a constructor. I just don't like throwing exceptions in constructors, so it's a separate function. What's the question here? Yes, so the question there was, what is this no discard in the attribute over here? This is because my IDE nags me about it if I don't put it in, because clang tidy nags me if I don't put it in. What no discard means is that if you don't use the return value from this function in any way, if you don't assign it to a variable or use it in an expression, the compiler can choose to give you a warning. It doesn't have to, it's not normative, I don't think, but it's basically saying, like, if you're calling name on my class and you don't do anything with the result, you probably make a mistake. The motivating example for this is the clear and the dot empty on any SQL like a vector. Is clear, does that clear it, or does it return if it is clear? And does empty, does it mean empty the container, or does it mean it is empty? And obviously, if you call one of them and you don't like look at the result, then you probably made a mistake. If you call dot empty, thinking like, hey, it's empty it, then you get an that's now mark mode discard, and it'll say, hey, you didn't use the return code from empty. You're like, oh, I see, that's the one that returns a value. So it's just, you'll see it everywhere in the code here, but thank you for the question. All right, I think we move on. Because more and more people are looking worried about the weather, quite rightly. So if you need to wave at me and tell me that we'll need to run out here, thank you, back. So we're now going to start moving more and more functionality in, and we can write some tests. So we'll move on. This is what it ends up looking like. It looks like an actual class object. You know, we've got, I'll show you the test in a second, but I renamed name to description because that was better, and area name to short name, which is a slightly better way, at least I know roughly which of those things correspond to. I have now written a constructor and I've defaulted it on purpose, and it's in the private area because I'm going to say to you, you can't make an area, you always have to call this static function over here to make an area. So I've chosen to sort of use this name to constructor pattern where we're going to return an area by value and we'll call parse and give it all the bits and pieces it needs, and rather than giving a constructor, just because anything that's involving a file and parsing can fail, and so I like to think that maybe I could make it an optional area or it's like throws an exception or something, whereas a constructor I'm always a little bit like surprised when it does weird side effects. There's a wish others go for a quick question. So the question is, can we just delete the constructor? Unfortunately not, because I need to be able to make one over here in this method in order to be able to fill it in with all the fields. So I'd either have to make an area constructor which takes all of the parameters, which is private, and is used by parse, or I'd have to, otherwise you're stuck. If you can't construct the object in the first place, not even your friend function can make one of these. Okay, thank you for the question. I started moving some behavior into here. There's some counting that goes on in terms of how many people are in this level at a time. So I can actually say, hey, I can add a function for this. There was like a boilerplate piece of like 6 or 7 lines of code, which is if there's no 0, then add 1 to it. And if it's now gone from 0 to non-0, then call some function which says, hey, this area is now alive. There's some human now walking around in this area, start spawning monsters and all that kind of thing. So I can move that out. And then there's an update function which was somewhere else in the code base. It's more like this is what we do every second. We will like update all of the game objects. And then there's your short name which was renamed. And now we can actually test this. So I use catch2. I know there's kind of like catch2 and Google test. The kind of two major ones out there. I'm partial to catch2 because it lets me set up scenarios a lot easier. I did write a very simple wrapper function around files. So in Unix, you can make a memory-backed file, and you get a file star that actually corresponds to a block of RAM that you've got yourself. And so this just wraps those functions with a little sort of RAAI style object, so I can actually inline define an area file as if I loaded it from disk, and then I can present it to my code as a file star in a nice way. And so I do a simple thing, and I can just check, hey, did it parse out okay? There is some gnarly, horrible A to I what's going on here. You can see it is actually reading the 1 and 50 from the string. So it's less trivial than you would think it ought to be given what is going on here. So there is actually some worth in testing this. And then once you can test it, you can rename things. So I did show these the wrong way around, but I should have shown you the pre-rename. Fabulous. Okay, so that's the general way that we're going to move forward. And now I'm going to show you some of the cooler things that you can do with modern C++. Modern, again, with my little air quotes. Obviously, it's a string processing program. It does a lot of string formatting. And this is how it was doing it before. I sort of read it out before. Char buff max string length. I think there were somewhere in the region of 800 references to char buff open square bracket max string length. Like literally anything that has to do anything with the user would make its own personal little buff that it would then protect into on the stack. And then hope to high heaven that you weren't printing more than max string length characters into it. So obviously, as modern programmers, we look at this and we go, this is terribly wrong. So step one could be as simple as let's replace it with SN and printf, and then at least I'm not going to write off the end of it. Still not much better, but it's better than, some kind of CVE on your running Unix daemon that's open to the internet. But if you're going to do this, obviously this is more boilerplate you're moving around. So why don't we take this whole formatting nonsense and push it into the thing that we're going to send the text to in the first place, which is like we've now got a character class. You have to assume that I did that same process to all of the other big structures of the game, one of which is a player character. So what do I give a method to the player character? Like, hey, I'd like to send you some text, format it, and then send it down a Unix TCP connection, whatever you're doing with it, right? And so, of course, if I just literally pick it up as it is, we can use our good old ... and printf style magical thing here, and then hidden inside of that char send to is that horrible fixed size buffer and the SN printf. And, we're a little bit better off. But, cool kids, remember to put the printf attribute in so that you get the compiler giving you some help. But the coolest kids of all, of course, don't use that at all. We move on to something using either lib format or standard format in C++20. So this is the new cool way of formatting strings that isn't IO strings, which I think we all broadly acknowledge is a bit of a mistake. Don't write for me, don't at me. So here we've just got, it's dangerous things to say in a room of C++ developers. I don't know how dangerous that is actually. Anyway, so char send to, we've got a base case which is just going to take a string view. And a string view is a nice way of saying it could be a char star, which is terminated with a null byte. It could be an arbitrary subsection of someone else's char star array, or it could be a standard string. And I don't need to care which of those three things it is. I can accept any of them, and as long as you don't need to then turn it into a standard string, which we don't in this case, it's probably best to be able to say, call me with anything. And then I have a templated version, templated overload, which says, okay, I'm taking a format, and then I'm taking some variable arg template parameters. And then I'm delegating all of this to fmt : format. I just pass on all those arguments in the format and let it do the heavy lifting or whatever that it does. And behind the scenes, it's able to parse out this string that I've given it. And you'll notice that the little %s's and %d's are all gone. And instead we've got like a Python style splat, open close, squiggly braces. And you can format any object here, not just %s and %d. I don't need to remember whether am I putting a number here, or am I putting a float here, or am I putting a char star here. As long as there is support in format, you can add your own, it will be able to serialize your object as a string. And what that means, I've forgotten what I'm doing here, what that means is I could now, I don't have to worry if this was a std string or a char star, if any one of these things were. These are all numbers as it happens in this particular case. But if you recall back to the earlier code where I had to change the name to name.c_str, because it had to match with the %s, it doesn't matter anymore. If I use std format, I can use splat, and it doesn't matter if it's a char star or a string or whatever. It's right. So I had to go back and undo a whole bunch of the work that you were looking at me when I was saying that before. I have to undo a whole bunch of the formatting work because I no longer need to call .c_str or everything. It doesn't hurt me to, but it just gets in the way of readability. Quickly to show you. Yeah, so the question here was, am I using std format? No, this is using the lib format that was, because you only get std format in C++20. And actually, there's some things that I'm using which I've not made it into the standard as well, which I'll show you in a second. So this is lib format, and that came into the command. So that makes life a lot easier to do all the formatting, and it's just generally nicer to look at this kind of stuff. But I mean, full disclosure, I've been writing a lot of Python, so this just feels a little bit more like home now. I'm still trying to work out, this is completely exciting, if there's some cool way that we can, at some later point, be able to like put the expression somehow in the middle. If there's some kind of paper with a leaving barrier, it's like, can we write something where I can put an expression in here somehow, like I can in Python, and then unify the whole world. Anyway, enough of that. String manipulation. Again, if you're writing a string processing, as well as outputting it, you need to be able to receive strings and do useful things with them. There's a whole bunch of things that we can do. Capitalization, uppercasing, lowercasing, and I had a big debate on the train on the way in this morning on Discord with a bunch of folks. And in this world, and uniquely in this world, 7-bit US ASCII is completely fine, so I don't have to worry about all of the unfortunate Unicode issues that come with it, because it's definitionally US ASCII 7-bit. So uppercase and lowercase really can be as simple as Oregon, hex 20 or whatever. White space trimming, various case-insensitive matching and prefixing, parsing, tokenizing, all that kind of stuff. So the code is littered with hideous things like this. So this is a function which capitalizes a string, and this, what I mean by capitalize in this particular instance, this is not a sensible definition, it's just what the code does, is whatever string I'm given, I'm going to make the first character uppercase, and every other character needs to be made lowercase, even if it was uppercase beforehand. I don't know why this has ended up this way. This is where we end up. Now, well, the first thing you'll notice is it's returning a mutable char star. So this is saying char star capitalized const char star stir. It's horribly mutable because it can be, because it's going to return a pointer to a temporary static buffer inside this function, which is just a travesty, but it's very common in C. So don't do this. Don't learn from this. And that allows it to essentially launder this string, which was constant, and return a mutable variable to it, because it actually took a copy and is giving you a pointer to it, which, look, don't do that. Don't do that at all. And it does the obvious thing of saying that I go from one end to the other at this horrible lower macro. It does whatever the lower macro does. It's, again, what it was before. Terminate it, and then we put the uppercase of the first character at the beginning. Right, whatever, you get it. And then we horribly return the address of this static buffer. I want to get it off the screen. Right, in this instance, in the rare moment, I actually did do the TDD before I changed it. Right, I had it was a simple function that was by itself. I didn't have to worry about too much other things. I thought, like, perfect, let's practice what I preach. And I'm going to write tests, first of all, for the existing code and make sure I capture all of the various edge cases. Whenever I think about edge cases, I think about zombies, which I'm sure you do. There's a sort of slightly nervous laugh in here. So when I say zombies, what I mean is you test 0, 1, many, boundaries, the interface. Oh, there's a...
What's S?
I haven't got there yet. I will get there. She's challenging me. 0, 1, many, boundaries, interface, exceptions, and simple scenarios. I remember there. Something my nose there. In this particular instance, I'm only testing the case, but essentially what it says is, the first thing you should do with any algorithm you've got is try it with nothing at all, try it with one element, and then try it with lots of elements. It finds almost everything pretty quickly, and then some other bits and pieces there. So that's what zombies are. That's not my acronym, that's James Brenning, who is embedded in C++ developer, which is the thing, apparently. So this is my first attempt. It's horrible. I didn't like it at all. But, first of all, the notable thing is that I'm returning a standard string now. So I'm allocating memory, and I'm returning you your own standard string. It's beautiful if you want to mutate it, and no one else will suffer if you do. So you made your bed, you said, you line it. And I do some horrible things where I start off with the result, and I resize it to these slides, and I kind of go through it. It's just horrid. So I'm not going to do well on it particularly. But this is an interesting thing here. This was my literal first attempt at doing it. So what you can see here is this is result 0 equals stood to upper result 0. So effectively, I've just copied the whole thing and lowercased it. And I've unconditionally written to the 0th element. And I thought this was a bug. And that's why I did the zombies thing, because I thought that 0 is going to catch this. And nothing happened. I turned on every undefined behavior sanitizer I could find in the world. Nothing happened. And I actually put it in, there's a website you can put this stuff in. You can try with all sorts of compilers. I don't know if you've heard of it. And I tried it on Clang, every version of Clang, and it was fine. And eventually I realized, as distasteful and hideous as this is, it is actually well defined, because you are allowed to write to, you're allowed to read the end element of a null terminated string, and you're also allowed to overwrite it, but provided you only ever overwrite it with a null byte. Now, in the case that we've got here, and the string was empty, 0 is a null byte, and stood to upper of a null byte is still a null byte. So, unintentionally correct behavior, but horrible. Don't do it. So I was a bit disappointed, when nothing happened. So you can see, this is my second attempt, and I actually special cased that at the beginning, like, if not stir, return an empty quote, because I thought I had to. Right? So was there a question or a thought? Yeah. If it was a null pointer, if the address... Back in the previous one, you mean? Yeah, if the result had zero elements, it is still well defined to do this. You're allowed to look at the 0th element of an empty string. I thought the same thing, and I thought, oh, maybe it's a small string optimization saving me, but no, it says you're allowed to read and write the zeroth element, even on an empty string. Because you're allowed to pass it to a C API, for example. You can do .c store on it, and it doesn't do any allocations or anything, and it will return. So if, whatever trick it's doing to give you a pointer to the null by, you can still risk, it will do it for you for this. Let's not get, thank you for the point. We can definitely over a beer talk more about it. But yeah, I honestly, I thought there's so many people who are like, no, it's fine. Like, it isn't, it's got to be not fine. All right, so then I thought, Sean Parent and the like love to say no more loops. And I'm not necessarily sold on that myself, because I tried doing no more loops, and I've got a std transform in here. And I need, in order to do a std transform, I need to start at the beginning of the string and then have an iterator to the end of the string. Of course, I've got a C-style string here, so str and str plus str and str. And then I need a back inserter, of course, because that's how you push it to the back of an existing string. And then the thing I'm going to transform it with, you would like to be able to put std to lower in here, but there's two reasons why you can't just put std to lower as a function here. One of which I knew about when I wrote this presentation. The other one I learned this morning on the train, so again, this is going to be a bit off the cuff. So the annoying thing is, or otherwise, std to lower takes an int and returns an int. It doesn't work on chars, it works on integers. The reason for this is you're allowed to put EOF through it, and EOF is -1 on most platforms, so I don't know that it's specifically defined as such. So it has to be able to return EOF, and the only way you can guarantee that it can return EOF in the presence of, I don't know, unsigned chars being the default, is to be able to return an integer, which definitely can't have a negative number. So, blah. That means that I can't just put the std to lower here, because this transform is expecting to be able to call each element with a char and get a char back out, and it will immediately complain and say, well, that doesn't fit, I can't call it in function with my char function. The second and slightly more insidious reason is that I don't believe that you are allowed to take the address. I'm going to look at the back for people who are more in the standards committee than me. I don't believe you're allowed to take the address of std to lower, which might be happening somewhere in the transform. And I'm not sure if that's true or not. Or certainly when I do the ranges thing in a minute. I'm very Anyway, it's too small for you to see. That's a perfect excuse. Anyway, so I do the whole thing here, I transform it, and I uppercase the end of it. And again, it's sort of unsatisfying that this is longer than the original bit of code, however, this takes all that was. So enter string view, which we've already seen, and I've forgotten. I'm going to re-enter string view and ranges v3. So the standard library now in C++20 has ranges, subset of what the range v3 library has. And C++23 has even more ranges stuff. So I'll tell you what ranges are in a second. If you don't know that, but to sort of for small questions, this is using ranges v3 as it was about a year ago. So what is a range? A range, logically, at least to me, I realize there are people in this room again who know far more than I know about this. I think of it as logically kind of a tuple of the begin and the end of the container. So normally we're used to passing around two iterators to any kind of algorithm. This is where I want to start, this is where I want to start. The range kind of binds them together and says, well, this is a bit more convenient. So that's number one reason why range is better. The end now doesn't have to actually be a real thing. It's not like it's the one past the end of anything. It can be a sentinel magic value, which now allows ranges to be infinite. You can have a range that says, give me all the numbers in the world, and it'll just keep counting up and counting up and counting up. Like, well, what's std end? Well, it's infinity plus one. You're like, well, that's a problem with that. So we need something magical that isn't a number that could be at the end of an infinite range, and that allows us to do some further things down the line. Pragmatically, this is the best reason to use ranges. If you've ever used std some algorithm, and then you've done begin of container, comma, end of container, nowadays you can do ranges, colon, colon, some algorithm, the damn container, because that's always what you want to do, right? So the container itself is sort of naturally its own range. Conceptually, it always sort of behaves as if it's begin and end range, which is just super convenient. So if you need to sort a container, ranges, colon, colon, sort, container. Hooray, no more begin, end, for instance. And then the real cool part of ranges is that they can be views of other ranges. So they can do some kind of transformation lazily as you read through them, and then you can compose them with the pipe operator. So you can start writing little Unix shell scripts in C++. Who doesn't want to do that? I'll show you in a second. So this is a starting point. So this is another way of writing capitalize. We're going to take a string view as text, which now means we can take a char star, a standard string, or a string view, and it all just works. A string view is a container, which means it works like a range already in the context of using these ranges. So now what I can do is I can take text, which is implicitly a range of all the characters in text, and I'm going to pipe it through a range enumerate view. What that enumerate view does is it takes every element of the input range, and instead of just passing it through, it gives me both the ordinal value and the value. So we're going to get like 0 and the first character, 1 and the second character, 2 and the third character, and so on. It's hard to do right in the presentation because it's 0 and 1, right? And then that is going to be piped into a transform function, which is going to receive that pair of values. And now the transform in this instance is going to be, well, if it's the first character, now confusingly, of course, because this is a double pair, this first here means it's the first of the pair of things that are passed in, which just happens to be the ordinal value. So if the first is equal to 0 means, is it the actual first character? Then we're going to 2 upper it, else we're going to 2 lower it. And then we're just going to filter through, and then the last bit is we're going to say, well, that's still a range. Until I read through that range and turn it into something, nothing happens, and they're lazy. But there's a convenience function in radius v3 that says, hey, take a range that's as input and just put it into a container, please. Please put it into a container, and that container shall be a standard string. So here in 8 lines of actual code, we've done the same. There's a question over there. Sorry, could you repeat the question? I heard it first. Right, the question was, am I making a copy of the text into the pair? Yes, effectively I am, because it's an actual pair of a size t and the chart. But of course, it's 1 by 1 is happening, so the compiler gets to see, oh, I see what you're doing. You've essentially just done for I equals 0 to the string length, pair equals I, comma, thing of I. And it's like, well, I can optimize this away, it's going to disappear away. Michelle was first, and I'll come over to you. So the question was about ranges. I don't know enough about how the standards, the library has finished up. I know, for example, that there isn't a ranges 2. So I'm not qualified to answer that question, I'm afraid. But I know that I'm implicitly relying on some magic in ranges v3 that didn't make it into the standards. Question here? Sorry, I'm not laughing at you. I'm laughing because I had the same thought on the train this morning as I was looking at this and went, oh, you could use structured bindings there. It turns out that there was a paper written, and I'm only asking this, I only know this because Barry and I were talking just a minute ago. Unfortunately not, is the short answer. The lambdas do not allow you to take a structured binding. The question, sorry, was, can we have a structured binding as a parameter? Because then it would be convenient. I'll be able to do auto, app, or whatever, open brace, index, comma, character, and it would read a lot better. But I thought exactly the same thing this morning. I don't know if that's, I said the observation there was we can do this as equals plus 20. That might be true. I tried it on, again, famous website, and it didn't work, and I believe it's not actually the case. So it's, okay, on Clang it may have worked, so I don't know. There were some papers, again, I'm acting as a terrible proxy. We can talk about it afterwards, actually, but there's a question right at the back.
It is 2 parts. So first, have you run all of these through your website?
Yeah.
And have you looked and compared at the assembly that's output?
So the question,
the lengths?
The first part of 2 questions is, have I looked at the code generation for this? Absolutely not. No, despite a website making it relatively convenient to do that, I was trying my best not to get totally typecast as a person who only uses that website during these presentations. So I haven't done that. And also, one of the things I didn't say at the beginning is that performance was never an issue here. This was running in a time-shared 200 megahertz machine with a whole bunch of students for many years, and so it wasn't a problem. But it would be interesting to look at it. I agree. And in the second part,
it's going to be faster than any computer notes, of course, but just out of curiosity's sake, because of convenience of the semi-readability of ranges, I was curious.
Yes.
If you have run any.
So
I very different code.
The question, or the observations were about performance of this, and my instinct is this: the performance of this is catastrophically awful. Would be my instinct, because I've done other aspects. I've looked at ranges before with some other code, and I think it's fair to say that improvements can be made in the code gen and probably the way the libraries are phrased, charitably. Again, I'm aware there are people here who know much more than I about this. So I haven't looked at it, but I imagine it's quite bad. So another question there, Michelle? Quick, if you could. Yeah. So the suggestion was to make a follow-up maybe where I do some of those things. I agree that might be interesting, but in the interest of getting through this, because we're only about 10% of the way through this presentation. The secret here is there's a progress bar at the bottom. You can see how far we've got, and I can turbo through this. So let's sort of use everyone's look of like disdain. You're stuck here. Oh, that's true. Yeah, nobody wants to go outside.
You do this favor.
Fabulous. Okay, we're going to press on for now. My favourite way of phrasing this with ranges is, forget which highlights you put in. I got really excited with reveal.js and there we go. Oh, look, and so yeah, there's me explaining the forget all those things. Right, this is the cool way of doing it, I think. So what this is I'm concatenating two ranges. The first range is the text where I just take the first character and turn it to uppercase. This is a bit suspect here. This two upper here is cheating slideware. And then the second one, I'm going to drop the first character and then take the rest of them and then transform it to and obviously then they're concatenated together and then I turn them into a string. So that's kind of nice. That's the first time where I actually use ranges in this code and went, that is actually better, I think. I think that's genuinely better. I'm getting a look from Barry, sorry. Okay, but now we're going to see a very, very super cool version of where ranges it was hands down better than what was there before. He's just trying to dig himself out of any holes his brains may have just made. I needed a case-insensitive str, which if you don't speak Dutch, maybe, C, is find a substring in another string. So you want to do a substring search of strings, but I need to be case-insensitive. And the way that usually C does this is either there's an I for insensitive in there or a case. So depending on which flavor of Unity you are, you've got stricastra or stristra. The problem with both of those things is they no longer work with string views, because a string view is a super convenient way of saying I take any bag of continuous characters, but the string view doesn't guarantee that there's a null byte on the end, and that's what makes it useful, because I can substring for free any other part of the code and say, like, this is the window I'm interested in, and that's super useful. But all of the C functions will take a zero terminated string, and so I can't use them. Well, I could if I copied the inputs into somewhere and put a null byte on the end. That kind of feels a bit smelly, so we're not going to do that. This is what the original code looks like, and it's just catastrophically awful. One of the more amusing things of this actually is that some of this code shows the very early optimizations that the original author, which was not me in this particular case, was doing. So nobody trusts the 1990 era compiler to do any kind of optimization. So you'll notice that it does all these horrible assignments to C0 in an if statement and then comparing it with the null byte to kind of pull the first character, the lowercase version of the first character, and then in this inner loop as it's searching through the string, it's checking to see whether or not the first thing I have to do is the first character the same. And if the first character is the same, then I'll go and do the actual check, otherwise I'll just play on. And you're like, surely the compiler would notice that's the very first thing that has prefix does, but we couldn't trust it back then apparently. There were several instances of the register keyword in here, which I managed to remove because I don't believe that they were doing anything useful anymore. So horrible, let's not look at it. This is the beautiful ranges version, which again is too small for my friends at the back. So this says matches inside, string view needle, string view haystack. And the first line says, clicky. Also, needle underscore low equals needle, pipe through, ranges, views, transforms to lower. So what I've got now is I've turned the needle into the lowercase version of the needle, but I haven't actually done anything. It's just a range, a view into the input, where I'll be lowercasing it every time I do any look at any of the characters. So I haven't made a copy. And then the haystack row is the same thing with a haystack right through to the. So now I have two ranges, which are the lowercase version of the needle of the haystack, and I just use the regular search algorithm, which says, can you find this range inside this other range? And we're done. And that's really quite, the first time I went, you know, this is definitely considerably fewer lines of code, which are quickly. So the question is it making a copy? To the best of my understanding, no. We're actually just making two ranges who are effectively adapted iterators, where every time you read a character from them, it's doing the to lower there and there. And so the code generation may be absolutely catastrophic again, maybe terrible. I don't think it would be. I think a lot of the compiler will be smart enough for that observation. Yeah, so it's right. So the observation is this. Right. I don't know what's going on inside the search here. We're talking about the time complexity here, which is definitely not something I'm confident talking about, so I'll defer to you on that. But again, it was fast enough for a machine that used to run at 486, so we're all right. Some more fun with ranges. This is another aspect of where I'm using a range and I'm using it with libfmt. And unfortunately, this I don't believe made it into standard format either. So to sort of fulfill that question here. One of the cool things here is this is when you leveled up and now you've got all this sort of these points to spend improving your character, and you go to talk to your guild master, and your guild master, you say, hey, what can I train? And the guild master says this to you. So you can train, and then it gives you a list of all of the attributes you can train: strength, dexterity, constitution. And then you can always train your health points and mana, right? They're always at the end. Doesn't matter whether you reach the limit of your strength and dexterity for your character class or whatever. And this used to be a giant amount of lines of code, with all horrible warty edge cases for like whether you put a space or you don't put a space between them. You know, everyone has to do this. But FMT lets us do this by saying, well, I'm going to treat a list of things as a single object. So I'll just put one splat there, which just says you can train open squiggly, close squiggly. And then the thing that I'm printing is an FMT join. An FMT join takes a range as the first parameter and a thing to put in between those things as its second parameter. So what this is going to do is it's going to put spaces in between all the things that are in the range that I'm giving it. And then the range is a concatenation of all of the statistics that you've got filtered by whether or not you can train it or not, transformed to the short string of that statistic. So that means it goes from the object that says I am dexterity to just the string DEX. And then it's concatenated with the list of things that are always trainable, like HP and mana. So I don't have to special case anything. It's just one range list and the spaces in between in the right spot. And that was kind of cool. As you can imagine, normally you have to remember, have I already outputted something? If so, I always have to add a space before I output the next thing. And then when you've got this list of things, which one thing's dynamic and one thing is constant, there were 2 bits and there were all these different Boolean values that had to be checked or whatever. So this is quite cool. Again, I'm sorry it's small for those folks at the back who are squinting away trying to work it out. The slides will be available. It's just a lot of miscellaneous stuff here as we get towards the end of it all. Just by replacing arrays, old style C arrays with size types, we've all seen these, some of them will be a hash defined max underscore AC to be like 5 or peanuts like that. I still have max AC, but now I can make it context for it because that's the new hash defined, right? And then I can use a std array, and now a std array is an actual container which works like a range, so I can just use ranges fill if I need to set all of the values to -1 because he just died or whatever. Right? That's kind of a sweet thing to be able to do. Another neat trick, I got a bit carried away. Once you start playing with a new toy, you start kind of going, well, I wonder what else I can do with this. So this is the yell command of the character. So if you type in yell space and then anything, what a yell says is it says to you, it says, you yell, whatever you typed in. And then to everyone else in the entire mud who is in the same area as you, it says, that person, your character, yells whatever you said. So first thing we do is we send you yell to you. It's complicated to say, isn't it? And then we say, okay, for everything else, ranges for each, take the list of descriptors. The descriptors in this instance are all of the connected TCP connections that actually have a real human being on the end of them. There are some edge cases to this because if you're a DM, you can actually take control of a non-player character and move it around. But you still want to be able to see things like that, even though you're not really a player character. So it doesn't matter, in descriptors. And I can say, hey, all but this. Now that all but is hiding the fact that I'm piping on a filter from the range. This returns a range that goes over all the logged-in people. All but says filter it except for this whatever I pass it. So in this instance, it says ignore me, ignore my character. And then filter it to be only the ones that are in the same area as this character. And then take the descriptor you're left with, which again is a units-like pointer, and turn it into the character, the char. It's horrible, the char, like as in like player character. That's at the end of that connection. And then we're going to pass it on to a lambda function, which has now got, instead of like a units domain thing, it's got the actual object that I can send things to, and format things to, obviously, send and we say, send line, this thing, describe this person to this other person, this describe for these, like if you're invisible and the other character can't see you, or if they've been blinded or whatever, it's just someone instead of like Bob. So that was kind of sweet. I ended up writing a whole palette of these things, and tons and tons and tons of code that was previously doing the boilerplate iterate over the descriptor linked list, which again was like another bespoke linked list. And there were like 28 different if statements that were like, oh, if it's this thing, continue, or return, and you're like, oh, was it continue or return? It all goes away, and you're just like, no, just for these things matching this, it's more like SQL at this point. Yes, question front. So we've had the M word mentioned. So a design pattern reminds me of a monad, yes. Yeah, that's the kind of way I think about it. And like monads are like those things where I like to pretend I understand them. Right, so yeah, some things there that I won't repeat because I'll get them wrong and I won't put you make it sound like you don't say the right thing at all because I don't know enough about it, but yeah, like a changing thing. I've seen it used in like optional, some optional type things where you can map over those and stuff, but that's a whole other talk. Okay, there is tons more than this obviously, but I'm obviously reached the point where, oh, it's actually brightening up, so maybe I could maybe go outside soon, feel good. There are a ton of other things we changed as well. And I keep saying me, and it's we, because there's a lot of people that are working with this, most notably my pal Rob. Not that Rob, different Rob. So we also brought in a strong type library for like integer types. So, like Boost has one, and there are various other ones around. I can't remember which one we actually brought in now, but like there are tons of things that are essentially num values that are just numbers. And we want to be able to say, no, this is different, this number is different to this other number over here. And obviously you can use it num class at some level, but there is a whole bunch of things where arithmetic is being done under certain limited cases, and you want to be able to support some of those things. In particular, this bit field thing was a real problem. Memory being tight in 1994 meant that everything was packed into tiny little structures, and so like every character has like two 32-bit values that correspond to all the 64 possible flags that you might have applied to you, with all these arcane rules about which ones can be and cannot be applied. And of course, they're just numbers in the code, and often they're just like 1 shifted up by 62, and you're like, thanks, that's great. So, it's nice to give them names, and it's nice to make sure that 1 shifted up 62 in your which spells are affecting you is different from 1 shifted up 62 in what attributes are you vulnerable to, right? And so you don't accidentally all the wrong thing into the wrong bit set. So that was useful. There are a number of places where we're able to replace hideous void star things inside function pointers with the good old void star vo as the second parameter to go like, I don't know what this is, you figure it out, and then horrible casts. So we're able to use function for that, and stood variant as well, which allowed me to, again, like take something which was a number of 2 or 3 different things and actually express that in code instead of just crossing my fingers and hoping to God that it really was a character pointer that was a number of stuff. And then stood optional in places as well, which is much better if you can use the monadic version, which Tartan was done. I was definitely now. So what do I regret? I really should have fuzzed this. This is a poster child for fuzzing, right? This is user input coming in, and there are loads of cool libraries around these days that will fuzz your code. And if you know nobody knows what fuzzing is, it's like a code generator of sorts is trying to find holes in your program by giving it inputs over and over again. And often your code is instrumented in some way, And with a combination of things like the sanitizers that said you read off the end of an array, that's bad, didn't necessarily crash you, but if it was a security person, they would probably find a way to hack your program knowing that you read or write at the end of an array. And annotations on branches so that the fuzzer, which is changing the inputs, is trying to make it so that every branch is either taken or not taken in your code to try and expose the different code paths inside your code. It's amazing how clever these things are at finding horrible things. And literally every time I've tried a fuzzer, within seconds, and they can run for hours right before they find anything, but within seconds, embarrassing things are found. You know, like the first time you write tests, you know, who here has written code and gone like, can't possibly make a mistake in that, and then someone goes, then you kind of think, oh, someone's going to moan about it in the code will be on there, and you write the obvious 3 tests, and then you're going to check it in, and then 2 of them fail, and you're like, oh, yes. So, it happens to us all. I never got to unglobal, you know, those things with globals. I haven't yet come up with a decent enough pattern for taking stuff that was very, very global and starting to like unglobal it, deglobal it. I've collected together some sets of things that go together and put them in another structure, and then that's now the global. And I'm hoping eventually that structure can be like, oh, this is the mud class, maybe the sort of like the God object of the world, and then I can start putting functionality on that, and then things can start disappearing. And effectively, it's no longer global as much as the one and only variable stack frame is name, right? You know, and then it's just mud.run. But I haven't got there, and obviously, as Michelle has asked me several questions and stuff, you know, I haven't really looked at the sequence 20 or 23. I would like to, but I'm scared because I think I'm using lots of cool things that aren't actually in the standard. Go on, Michelle, last one. Yes, sir. Right, I will get to that at the end. Right, so the question was, is it on GitHub? And the answer is, yes, it is. You can have a laugh at it. So this is where I get to pontificate for 2 minutes in what passes for a conclusion in all of this, which is, well, first of all, total surprise to me, I did indeed reduce, despite all these improvements, I did actually reduce the code size. So most of this was like the horrible boilerplate that was going on, all the iterators, you know, macro-ish things that were going over, and deleting code that couldn't be reached anymore, that was discovered by actually reading the code and going, oh, we never finished that, we should probably just take it out. So that was an improvement. I was expecting to go up, right? I was expecting to be more wordy in a lot of ways, so I was pleasant surprise. And then the other thing is, if you remember, we had like 700 lines of Perl and make, and now we have 93 lines of CMake. And again, I'm not a fan of CMake, but that's definitely an improvement, I think. What helps us along the way, you know, warnings. Hopefully everyone here knows that they should turn on as many warnings as they can reasonably tolerate in their day-to-day. We should be all of them, all of the time, in my personal opinion, but you know, your mileage may vary. If you are writing libraries for other people to consume, then consider not turning on all the warnings by default, because otherwise other people's compilers may not like that. Or there may be false positives and things, but if you can possibly do your own, then turn the warnings by making errors. Don't let them hide, because the compiler is trying to help you. Use all the sanitizers you possibly can. I generally try to leave the sanitizers on my debug builds, which means all my tests run with the sanitizers on. And it can slow things down. Back when I was writing C++, it was high performance C++, which was great because even the debug builds were fast enough to run with the sanitizers on at the time. And in fact, in some cases, I was able to run my production systems with enough of the sanitizers on to kind of like develop some confidence that nothing horrible was going wrong. And obviously, we're already using compiler Erica in development there, so I don't need to tell you about that. And then, yeah, obviously, what helped here was backwards compatibility. There was no way I could have done this if I wasn't able to just take that code and accept a class and template, just get it compiling and running almost straight away. And so, what does this mean for us, though? So many slides. Yes. So why would you modernize your code? Let's imagine you have got 30-year-old code, and you're like, yeah, I'm charged with looking after this piece of code. The best thing I can do with it is leave it exactly where it is and never ever touch it again, right? I mean that is not a bad thought if you're in that situation. But if you do choose to modernize your code, it is much easier to find and fix bugs when you're using modern idioms, and things like the sanitizers work better when they know where the extensive things are, which is definitely a bit easier when you've got things that have sizes like strings rather than just arbitrary buffers that are 1K because you think that's going to be big enough. The code is hopefully more understandable. And obviously, I don't know about you, but if I was charged with, looking after a 30-year-old piece of code, I couldn't actually change it. I felt quite quickly that my skill set was atrophying, and it would be nice to actually use these cool new things I keep hearing these conference talks about. So it keeps coders happy. And if you can do it incrementally, then it keeps the management happy too, because you're not actually taking the system down for 3 years while you're rewriting it. So, final conclusion. So, you can take code from yesteryear and have it work now. And that's a powerful thing that C++ allows you to do, which you can't often do with other languages. You don't have an expectation you can pick up your JavaScript code from the early days of ECMAScript back in the day, or whatever it was called back, and just it would work fine, right? The DOM has changed beyond recognition. But we can do this with C++. And so that's kind of cool, and maybe there's one or two people in this room that have code bases that are. But even in your day-to-day job, you can take advantage of this. C++ is sort of strong guarantees of backwards compatibility means that very often, when a new compiler comes out with C++ 20, C++ 23 features, you can turn on your compiler switch that says, oh, enable C++ 20, and run your existing code, and have a fairly high degree of confidence it's just going to work as it did before. That's sort of backwards compatibility too, right? And the other cool thing is that, having done that, you can now incrementally start legging into using those new features one at a time. You don't have to redo the whole world. You don't have to revisit the whole program. Maybe modules will break this. I don't know. I'm better than you tell you that. So C++'s backwards compatibility helps you in your day job right now. And the other thing is, of course, in the future, when you come back to your code in 30 years' time, it will probably still work, which is kind of cool, right? So I want to say thanks to a whole bunch of people who are on this slide here. The original ROM developers and my college roommates, and Hannah for doing this, the pictures, and the various people that helped me to run various early versions of this talk. And then the last slide, which is here, is yes, to answer Vishal, the source of this is all on GitHub. You can go and laugh at the code. You can even go and play it if you feel compelled to give it a go. It is quite unplayable and terrible, and there's not much help you along the way. But just remember, when you're running the code tomorrow, maybe someone will be compiling it in 2047, which is terrifying, right? Thank you very much, everyone. If there are any remaining questions, I'm happy to take them, but I'm also aware that it's 8 o'clock at night, and I've been talking for an hour and a half, which is a lot longer than what we were expecting. So, over to you. Anyone? Question at the front. Oh, yes. So the reminder of the string letter was the S at the end, which I actually now forgotten already because my brain. Oh, right. Is there where? Next one. The one's got the string. Oh, that's different. Right. I've gone back. I was going backwards. There it is. Okay. So this is another cool thing. I'm going to use my laser pointer because I've got it. The SV at the end of this quoted string here is a suffix for a string literal. The SV in this instance means that that quoted string of a single space is actually a string view. So it's the same as writing string view, open parens, quote, space, quote. It's just much more convenient. You have to, somewhere hidden in the slideware above this is using namespace std literals, which is the one and only time that you can unambiguously write using namespace something and not have someone come past with a baseball bat and hit you, because you should probably not be doing that most of the time. Right, so the observation is you can put it, so sometimes the trick is putting it in headers. There are some cases where you want to define like a context for a string literal that is a string view in a header file, and then you're stuck. There's no way that you can use a string literal like SD in a scope that's like header space. It's really, if you do it into the body of a function, but you can't be using namespace that without like cursing the rest of your program to have the same namespace thing that we're trying to avoid in header space. So easy, wasn't it? Was that sorry then? Oh, yeah, you could use it was an anonymous namespace and then like you're using, oh, right. Yeah, detailed namespace is what, sorry, that's right, yeah. Is that another point? Yeah.
So, this is how maybe more modern, it's more modern language, but we think that this is works, it's changing the art, like the large scale architecture.
Right.
Like the design patterns.
Absolutely. So the observation was that this worked well for like transliterating the existing code pretty much as it stood in terms of the broad design is the same. But how might one go to start making it more, changing the architecture as well, which is definitely. Now, so my thoughts about that, a little bit of it has come out in this talk, is that once you've got objects that are wrapping obvious areas of the code base that like contain responsibilities associated with one thing, it might be easier then to say, okay, now I can aggregate them in different ways, or I can refactor them in different ways at that point. And also you've written some tests hopefully, so you might be reasonably sure that your system is going to run. But it is a whole of this. This is only really good for like bringing up to speed. It doesn't necessarily give you a panacea for like fixing the architectural mistakes of your 19-year-old self. Another question, I think. Yeah, so the observation was like working on smaller pieces and then bringing them together is probably better. Right, so if you've already put it into smaller pieces, then it becomes easier to make architectural changes. So yes, it's a similar kind of thing there, but I don't know that there's a good solution to that problem more generally. I think we've all faced up to things where it's like, I really have made a mistake in the design for this and I really need to change it, but I'm terrified to do so. Any other questions? I have that explode. We need what you recommend is so the question is, did I compare the size of the executable before and after and all the memory usage? No, and again, I'm scared to do so because I'm pretty sure it would be awful. Again, it's not necessarily the case that I've optimized for anything in particular, other than ease of writing code here. Yes. Anybody else? Any other thoughts?
One other for the services.
Yes. Exactly. That's the trick. So the observation there was if we went all the way back to my needing pointer stability in my rooms that had pointers to the areas which I put into a vector, very often you can use an index instead. And as long as you can always know which container this index is good for, then you're in a good spot because that doesn't change. And I'm sure you've done this as well. We've worked in similar industries. There are ways of like tying the index with like tag types for which thing it comes from, and like pressing the pointer down, and sort of like making it still look like a pointer. You can hide the fact that an index the value is actually an index of this array. It looks like a pointer. So I didn't think about doing that, but then I realized I was going down a rabbit hole rather than the data of it once again. No, this is not what I need to do really. But no, that's a good point. Right back there. Sorry, can you using patterns? So the question, if I'm going to get away from the speakers, was, am I using some kind of test-driven development framework and am I able to stub out the files and things like that? I believe, is that a fair assessment of the question, do you think? So I am using Catch2 only as a test framework. And then in this particular case, I am using, for the few cases where I've introduced interfaces, new interfaces, which I don't have any examples of here, I use Trompe L'oeil, which is impossible to say, otherwise not very popular, as my sort of mocking framework. I'm trying to reverse back into where that code is. So that one's one slide of testing it. Oh, there it is. Yeah, so this is catch 2 style testing. This doesn't exhibit any mocking or stubbing, and the mem file thing that I was showing you where it was loading from the file, that was something I wrote myself. It just happens to wrap over with file style, and it's all of like 5 lines of code. It's not a very big thing, but if I was doing it properly, some definition of properly, and I was replacing the file style, the shoutcats file style, which is obviously still a very C API, with something that was maybe an interface to something which could load lines of text or load bytes or whatever it's doing, then I would consider using Trombone to then mock out that, and I wouldn't even need to have a real file of any sort anyway, even if it's in the test file itself. Does that answer enough of your question? Thank you, thank you. And another question, Michelle? Yes. So the question is, could we add a GUI to it and make it a graphical view? That, yeah, I have got a branch of this which uses another one of my projects, which is a C++ WebSocket engine, and then I serve up a terrible like JavaScript frame, and then it uses WebSockets to send the commands. And it's still like a Unix style typing thing, but it opens the doors to having like an actual interaction. It also means like you can go to the web, you don't actually have to use Telnet to get to it. But I didn't get very far with it, but that would be my preferred way of going, rather than trying to get, libcubes or whatever working on it. I'd be like, no, I'll just make a web page because that's the de facto UI, but everything means that is right. And so I have to cross-compile it to some weird language. Yes?
So many relocate still optional, but how will everything relocate before and how will it relocate now?
So the question was how was I using still optional? I believe the still optional was in cases where I knew that it could be reasonable that an error would happen. Anything, and I tend to use try whatever as my sort of style. So this is just a general style thing rather than anything specific to the mod. If something could reasonably fail, like, hey, read a line from a text file, it would be an optional string, and it would be like try get line would be my sort of preference. If it's exceptional, like I'm expecting it, and obviously your definition of what you're expecting something or not to actually happen can change depending on the context, which is half the problem why we debate about it all the time. I did use exceptions. And in my case, the exceptions were like if the program is open out. It's just a convenient way of saying we're done here now. It's a board but with a little bit more nuance to it. And also it's a board where I can write a test that says, should we encounter this thing, we will shut down in the right way by catching the fatal error type thing. I think maybe in a couple of cases, I do use it when I'm parsing numbers because it's super inconvenient. Again, so it's context dependent, right? If it was a human user typing in a keyboard input for a number, absolutely, it would be an optional int. It's like that may not be an integer, who knows? But if I'm reading a file off this, which ought to be in the format I'm expecting, then I will just use the convenience of like read an int, and if it's not an int, throw a blow up and I'm done here, or that kind of thing. And so the optionals weren't used as much as, and I haven't used an expector or anything like that. It already has. All right, I think. Oh, go on, last one, Bishop. You get the last one. So the question is, it's open source. I don't remember which license it's under, but it's permitted by anything I put on the internet, whether it's permitted as I can. I want to discourage anyone from thinking that I'm attached to the code in any meaningful way. You can take it and do whatever you like with it within reason. I don't know anything. So I don't remember exactly what license it is. I think because of one of the underlying things that we used, which I think is ROS, there is some very minor, like you must at least keep this particular line in the code somewhere thing. But other than that, it's just designed to get it. So yes, feel free to hack on it. Send me PRs. Almost certainly my mate Rob will be the person looking at it because I don't know quite the last time. Many other hobbies to run on at the moment, which. But okay, well, I think we'll stop there. Otherwise, you're going to politely sit here. Thank you very much for listening. And thank you once again to Rob for organising and hosting this and for the whole C++ Meetup. Obviously, you saw the URLs. Make sure you sign up for Mike's Curtis's talk, which is next time. Thank you to TechNexus for hosting us all. And thank you to Selby Jennings, oh my golly, I've forgotten them. And if you ask a lot of questions, you're welcome to swag. Currently I have 5 pairs of socks. Where's Michelle? Yeah, you are. You definitely get a question, thank you.